try to make a link with the Bengal Basin. So climate change manifests itself mainly through changes in the Earth's hydrological systems, and you can see a number of things that are listed here can be a manifestation of climate change. For example, higher temperature, changing rain and snow pattern, more droughts, warmer oceans, rising sea level, and so on and so forth. And on the right hand side, you can see, just to remind yourself, this is the hydrological cycle or the water cycle, and you can see different stores. For instance, you can see ocean in the right hand side, and then groundwater. Here is another store of fresh water. Above it, you can see soil moisture, and then you also see surface water and snow and ice in the mountains. So I'm not going to describe the hydrological cycles here, but just to tell you that these are the different stores of fresh water, and they're all interlinked. And how climate change is going to change the distribution of the freshwater store is a matter of concern. And I'll show you in a minute. Here, climate change impacts on freshwater store is actually going to affect by two different features here. First point here is the global warming intensification of hydrological system through net transfer of fresh water from ice and snow. The second point is the higher saturation vapour pressures that enhance precipitation and evapotranspiration. And here on the left hand side, you can see different stores that I just showed in the earlier slide in the hydrological cycle. From the bottom, groundwater is being the greatest, the highest freshwater store, which contains about 30% of total fresh water of the earth, and then soil moisture, which is very tiny, 0.05%. Surface water is about 0.3%, and ground ice and snow is about 0.86%. And you can see on the right hand side diagram taken from a recent review study published in Nature Climate Change by Taylor et al. That shows in a cross-sectional diagram, if you imagine from the Himalayan mountains all the way down to the Bay of Bengal, you cut across different environments, and how these different environments are actually being impacted by the climate change as well as human development, particularly more obstruction for irrigation and public water supply. I think I'm running a bit behind, so I'm not going to explain more. Let's move on. So the first point is the net transfer of fresh water from ice and snow through the melting of glaciers, alpine glaciers, continental ice and glaciers, and ice sheets. And you can see on this diagram that shows the distribution of continental ice as well as alpine glaciers. And here on this diagram that shows in the Himalayas there is a declining trend in glaciers observed in the east, the central part, as well as in the western part of the basin, western part of the Himalayas, whereas in the Karakoram mountains, which is the northwestern part of the Himalayan mountain chains, there has been a slightly rising trend in glaciers, alpine glaciers. Although alpine glaciers contain only 1%, less than 1% of fresh water, but it has a greater impact on the communities that are dependent on the melt water from these alpine glaciers. And in this diagram, taken from a study by Kaiser et al. In 2010, that shows that in two different climatic zones, RLC in the northern side of the northern side shown on the map. Here on the right hand side you can see RLC is being in the dry area, whereas the Ganges River, located in a humid tropical climate, are actually being affected differently by the glacier melts. RLC, for RLC, the delayed meltwater contributes significantly to the flow in RLC, whereas the contribution of meltwater flow is actually quite trivial in the Ganges. And the communities living in these two areas are going to be impacted differently because of this phenomenon brought about by global warming and climate change. If we move on to the next point, which is the higher vapor pressure enhances precipitation. The general concept is that warmer air holds more moisture. The increased moisture in the atmosphere is driving the shift to heavier but less frequent rains, meaning under the climate change, under a global warming condition, the tropics is going to experience more heavy precipitation events compared to the other parts of the world because of warmer air that can actually hold more moisture. So when it rains, it really pours. And the theoretical basis for the intensification of rainfall, as I mentioned, warmer air holds more water. And according to the Clausius-Clapeyron relationship, you can see at 0 degrees C, the moisture holding capacity of the air is 4.5 grams per cubic meter, where it increased to 30 grams per cubic meter at 30 degrees C. So if you warm the air, you're going to get more moisture, and more moisture is going to give you more rainfall. And often it's heavy rainfall. So heavy rainfalls tends to deplete the available moisture in the air. As the temperature rises in the tropics, it leads to greater increases in water holding capacity. So in the tropics, intensification of rainfall is projected to be the greatest under climate change conditions. What does it mean actually? In terms of crop production, it can affect negatively. For instance, this is a study done by Chaliner et al., published in 2006, who shows that groundnut production in Andhra Pradesh between two different years, 1975 and 1981, where the total rainfall was quite comparable. Actually, in 1981, the production of groundnut has actually decreased. Audience from India, particularly from Andhra Pradesh, can verify this. I'm not going to go into details whether all other variables that might also affect the groundnut crop production was taken in consideration or not. I'm not sure, but it simply shows that the variation in soil moisture, which is associated again with the rainfall intensity, can actually negatively impact crop production in some parts of the world. There are positive sides of the story as well.
I think we need to start taking questions in some time. So may I please ask you to start winding up in some time?
Yes. Yes, I think I don't have very many slides left. I can go through them very, very quickly. One of the positive sides of the intensity of rainfall is that the groundwater recharge, particularly in the tropics, this is a study done by Taylor et al., published in Nature Climate Change, that shows that that groundwater recharge results disproportionately from very intense and extreme seasonal rainfall. in the sub-Saharan Africa. And we know from Intergovernmental Panel on Climate Change, IPCC 4th and 5th Assessment Report, that the intensification of rainfall, particularly in the tropics, is quite evident. And this is again a study done by Portman et al. That shows how groundwater recharge is going to be impacted by climate change under different generalized circulation models, climate projection models. I guess I'm running out of time, so just to link it to the Bengal Basin, where there has been very little study on climate change impacts on groundwater storage. What we know, though, from a study done by a colleague at Engineering University in Bangladesh, that shows that climate change projected to intensify seasonality in rainfall over the Bengal Basin as well. So under the projected climate change scenarios, both annual rainfall as well as 90th percentile of the rainfall, which are the extreme events, heavy rainfall events, are all going to increase in Bangladesh as well as the Bengal Basin as a whole with time. And as I said, groundwater recharge is associated with the surface geology. So the areas of superficial clay cover give rise to overland flow, increased runoff, whereas areas of sandy soil with shallow aquifers get more recharge through diffuse as well as focused groundwater recharge. So it is highly dependent on geology. Again, sea level rise is another aspect of climate change that is going to impact shallow groundwater levels in the basin. I'm sorry, I'm running out of time, so I'm not able to explain to you all, but you can see on the slide. So just to finish off the webinar, what are the adaptation strategies that we can take? Well, first of all, one of the adaptation is going to be a careful conjunctive use of groundwater resources is necessary, and we can also use managed aquifer recharge in the areas where there is decline in groundwater storage in Bangladesh, and currently in Bangladesh, especially in the southern part of the country where groundwater is salty. Actually, rainwater is being harvested on the rooftop to then infiltrate into the shallow aquifer where there is salty water to provide fresh water supply through this managed aquifer recharge. I guess I've got 2 more slides. Again, the second adaptation strategies could be the implication of induced groundwater recharge through increased pumping, but we have to be careful. We don't want to pump everywhere. We have to identify the areas where the concept of Ganges water machine can be applied. We also need to identify the areas where it cannot be applied because of surface geological condition as well as the potential of groundwater recharge. My final point here is that rising sea level and coastal storms will impact shallow groundwater. So we have to carefully develop our deep groundwater resources with monitoring so that we can provide fresh water for drinking as well as for irrigation where it is necessary. I'd like to thank the people that I listed here, and also thank Meta Communications and the Water Channels and the viewers for listening to me. Thank you very much. I'm sorry I've taken long. I'll be happy to answer to any questions that you may have. And I can see Abraham has listed some of the questions here.
Perhaps we can begin with the question in red. The first one is from
red. Yes. I can see first question is about, could you briefly explain how the actual recharge is estimated? Well, I used water table fluctuation method that takes into account of the annual fluctuation of groundwater level, and you multiply that with a specific yield value which is derived from pumping test to estimate actual groundwater recharge for the Bengal Basin. The second point, how is the water machine allowing for more recharge in the northwestern of the country relate to declining groundwater levels in parts of the northwest below lifting capacity of the more simple techniques? Okay, when are we on the right side and when on the wrong side of pumping? Well, that's a very interesting question. As I said, Ganges water machine concept has been realized in the northwestern part of the country, not everywhere, some part of the northwest where surface geology is more permeable, that allows more water to infiltrate during the monsoon. So during the dry season, farmers have been pumping intensely. Very intense pumping has been taking place over the last few decades that has created more space, more storage in the shallow aquifer that was subsequently being filled up by the monsoon rainfall. So it is very, very critically controlled by the surface geology. If the surface geology is less permeable or impermeable, you don't realize that you don't get groundwater recharge to be increased, because it inhibits direct groundwater recharge. Okay, let's move on. Could you comment on the Ganges water machine and arsenic? That's a very interesting point. Although arsenic is one of the fields that I have been working on for last 10 years or so. I haven't talked about arsenic contamination in Bangladesh here in this webinar. Maybe I'll be able to talk in some other time, but I can this is very interesting, is that what we have found is in a recent study that is being reviewed in Water Resources Research that I have submitted, where I reported that the areas where groundwater recharge has increased has the potential to decrease arsenic by induced recharge and by dilution. So the areas where induced recharge has increased can actually have low arsenic. It's a matter of debate. We are at the very preliminary stage to validate this, but this is what I have found from a statistical study done at the national scale. Okay, other questions like Ganges water machine idea is hydrologically sound. Why has no authority in India, Bangladesh bothered to take up to implement this so far? Well, it's very interesting again. I'm also surprised why the idea, being so old, published in 1975, was not implemented at a very large scale. Well, what can I say? Well, it involves some initial investment. You have to build the infrastructure, and people had very unclear ideas about the potential of this potential of groundwater recharge in the past. But now, since time has passed, and we have demonstrated through our study that is published in Hydrogeology Journal a couple of years ago, that this Ganges water machine concept has actually been realized in many parts of the country. So people have actually have started talking about this old idea. Maybe in future we will see the implementation of this Ganges water machine in many areas in the Indian subcontinent. Well, we have to wait and see. Some other questions like yes, there are many advantages of underground storage. So why large surface reservoirs still the dominant thinking worldwide? Is that because hydrological studies are not so definitive that people can? Well, it's a matter of debate actually. What we see is surface water everywhere, although it only represents less than 1% of total freshwater content of the whole Earth. Groundwater contributes. Groundwater contributes 30% of total freshwater, which is not seen with our naked eyes. It's underground, and often we don't have enough study to actually convince the policymakers that there is plenty of groundwater under our feet, and we can develop it. If we develop it very efficiently, then that can be more beneficial for the people, for the farmers, for the economy of the country, rather than establishing or building large reservoir dams and storage. I guess we, like hydrogeologists, have to come forward with evidence that groundwater storage can be carefully used to adapt for climate change as well as human development in the future. So we have a role to play. The final question I can see here: what do you have to say on experiences and possibilities of communities' role in groundwater management? This is also very interesting. We often talk about community-based adaptation, and if we don't involve communities, then we may not have a successful adaptation strategies. So we have to involve communities. How do we involve communities? It's a matter of question and debate. I think local people have local knowledge, and the local farmers have better ideas about their groundwater system. They often know very well when the water table is rising, when the water table is declining, and I think we scientists need to engage local community people in the process so that we can inform them through our scientific investigation what is happening with their groundwater. And of course we have to engage policymakers and government and water managers as well in the process. Do we have more questions?
We seem to have reached the end of our questions.
Yes.
We have one more question. No, we have seemed to reach the end of our questions. So thank you so much, Shams, for your very enlightening presentation, and also thanks to the audience for the very interesting, questions that kept the discussion going and made the session very interactive. I would like to point out that a recording of the webinar would be available on www.thewaterchannel.tv/webinar. I will post the link on this chat box, and on that webpage also we have a list of the future webinars that are lined up, and recordings of past webinars, and resources and materials excuse me, related to our past webinars. So thank you very much again, Shams, and thanks to the audience who joined in. We will see you now at the next webinar. Thank you.
Thank you, Abraham, and thank you, dear audience. It has been a pleasure to give this webinar. So hope to see you again. Thank you very much. Bye-bye.